Okay, when you have fractions in your equations, clear the fractions off at one step. Let's look at the common denominator of all these fractions, which is 10, and let's multiply through by 10 on each side of the equation. On the left, 10 times negative 1/2 y is negative 5y, and 10 times 4 is 40. Goodbye fractions. On the right, the 10s will cancel when you do the first part of the distribution, leaving negative 9y. And then 10 times 2/5 is 20 over 5, which is 4. So I've cleared the fractions. There are no parentheses to distribute. There are no like terms to combine on each side of the equation. So now it's time to get all the variables to one side. And I will add 9y to each side of the equation to get rid of the y's on the left and bring them on the right and bring them to the left. So we will have 4y plus 40 is equal to 4. Finally, I will subtract the 40 on each side and then divide by 4. So subtracting 40, I now have 4y equals negative 36. And dividing each side by 4, which I'm going to illustrate, at least for the time being, is going to give us negative 9 as our solution to this equation. Notice I'm using the word solution, not answer. Equations have solutions, and negative 9 is our solution set. Sometimes it is actually written as a solution set using the set notation. Okay, in this next problem, I see parentheses and the need to do some distribution. So here we go. 0.4 times n is 0.4n, and 4/10 times 10 is plus 4. And then bring down the 0.6n equals 2. Now, normally I would clear the decimals by multiplying through by 10, but in this case I can combine like terms, and 0.4 and 0.6 add together to be 1, and I have 1n, or just n plus 4 is equal to 2, and subtracting 4 on each side, we get a solution of negative 2. N equals negative 2, which again, if you want to check it by substituting it into the original problem, you can. Okay, now let's look at a few different types of things that can show up. We've got 3 types of equations: conditional equations, identity equations, and contradictions. We have been solving conditional equations. They work, for example, in this last problem, it works in the case or on the condition that n is equal to negative 2. So the ones we've been solving that have a nice, neat answer are conditional equations. Let's look at the other two. Let's start, there's no parentheses, so let's start by combining like terms. On the left, we've got 2 sets of like terms, and on the right, we can combine the constant terms together. So 4z minus 3z is 1z, and 2 plus 5 is 7, so z plus 7. On the right, I have a z already, and then I have a plus 7 when I add the 3 and the 4 together. Now obviously we see that both sides are the same, but let's say we subtracted z on each side. We would then have 7 equals 7, which is a true statement. This is up above what we are referring to when we talk about an identity. When someone looks at themselves in a mirror, they see themselves. That is your identity, who you are. And in this case, the solution set is all real numbers. In other words, no matter what number you substitute in for z, the equation up above is going to work. If we write that in interval notation, our solution set would be from negative infinity to positive infinity. So in identity situations, you have a true statement. In this case, 7 is equal to 7. Let's look at this next problem. We see parentheses on the left, so we want to do some distribution, and that will give us 6z minus 12. On the right-hand side, we can combine some like terms. 3z plus 3z is 6z, and we have 6z minus 8. When I subtract 6z off of each side to try and get all the variables together, you'll notice that they cancel each other out and they disappear. And we have negative 12 equals negative 8, which makes no sense. So I'm going to change that equal to a not equal. And this is a contradiction. In other words, there is no value of z that will work in this equation, and so our solution is that there is no solution. So I will write the null set symbol here, or sometimes we write the empty set notation to denote that there is no solution to this linear equation.